Today is going to be our third day of solving equations. So our problem solving techniques are still the same. We always do opposite operations, and what you do to one side, you do to the other. So before we look at some of our bigger questions today, let's just take a quick moment to review distributive property from your Unit 1. Distributive property. Distributive property always just tells us that we have a number outside of brackets that we're going to distribute to the inside terms. When we distribute that 3 inside, we multiply it by both terms. So 3 multiplied by x, so I first do 3 times x, subtract 12, because then I'm going to take my 3 and multiply it by -4. Let's now see how this relates to solving equations. Our first example that we're going to look at would be 3 multiplied by x minus 4 equals 2x plus 8. So what we're still trying to do is figure out what can we substitute into x on the left side and the right side so that the statement is true. True being that the left side equals the right side. First thing I'm going to do is distribute my 3x in. 3x subtract 12 equals 2x plus 16. 2 multiplied by x and then 2 multiplied by 8. Now I need to bring all of my variables one side and all of my constants to the other side. So I'm first going to move my 2x, so that will become 3x minus 2x. Remembering that if this is positive 2 here, when it moves to the other side, the sign will change. My 16 was always on the right side of the equal sign, so we're going to write that first, and then I'm going to add 12 to it, because the opposite operation of subtraction is addition. 3 minus 2 leaves us with just 1x. 16 plus 12 equals 28. So then we want to check to see if we've done this correctly by substituting in 28 into the left side and the right side. So is x actually equal to 28? So I have 3 times 28 minus 4 on my left side, and then on my right side I have 28 plus 8. So 3 times 24 equals 72. 2 multiplied by 36 equals 72. So therefore, you know that you have solved the equation correctly. The statement is true when x is equal to 28. Let's move on to our second example. Example number 2 for today. It'll start -5 multiplied 2x minus 3 plus 1 is all equal to -3 4x minus 3 equal to, plus 21. So same thing, we have to remove our brackets first, so we're going to start with distributive property. So on our left side, we're going to have -10x plus 15. That's because the -5 times -3 becomes positive, plus 1. And then distributive property on the right side, -12x plus 9 plus 21. Let's gather all of our like terms. So I have -10x plus 16 is equal to -12x plus 30. Now again, I bring all my variables to one side and all of my constants to another side. So here on the left, I now have -10x plus 12x is equal to 30 minus 16. I have 2x, -10 plus 12 leaves me with 2x. 30 minus 16 is 14. Here we recall that's 2 multiplied by x. The opposite of multiplication is division. So we divide the left side by 2, and what you do to one side, you of course do to the other. My 2's cancel out, leaving me with a final answer of x being equal to 7. So if I substitute 7 to my left side and into my right side, my 2 equations will be true. Example number 3. Sometimes our fractions are going to come into play as well, that we reviewed in Unit 1. We also did a little bit of it in Day 2 when we were solving equations. 2x plus 1 divided by 3 is equal to 5. The first thing we want to do is remove our denominator so we don't have to worry about the fractions. So I know that if I multiply my left side by 3, if I multiply all of this by 3, my 3's will cancel out. And I can do this as long as I recall what I do to one side, I always do to the other. So I have to multiply my right side by 3 as well. Let's clean this up. I'm left with 2x plus 1 is equal to 15. I want my variable by itself. I'm trying to isolate for x. So I have 2x is equal to 15. Subtract 1 because it was positive here. When it moves over, it becomes subtraction. 2 multiplied by x. The opposite of multiplication is division. What you do to one side, you do to the other. So again, let's just make this a little bit neater. We have our 2's canceling out, and we're left with x equals 14 divided by 2. Therefore, x is equal to 7. And again, you always want to check your work on a test or on a quiz. Go back, substitute that 7 into your original equation, and see whether your left side equals your right side. I'm going to do one more example for you that has fractions, and then I'm going to leave you with one to try on your own. So our last example here is example number 3, and we have 2m plus 4 divided by 5, subtract 3m plus 2 divided by 3, all is going to equal 4 when done correctly. The first thing I want to do is I want to remove my denominators. The easiest way to do that is to find a common denominator. The lowest common denominator is best. 5 times 3 is 15, so that's common. So if I multiply all my terms, multiply all 3 terms by 15, I can remove all of my denominators. And don't forget this one over here on the right side. Frequently in the past, students miss that last term there. So now I can do some canceling. I know that 15 divided by 5 equals 3. I know that 15 divided by 3 is 5. And then I'm left with 4 times 15. Now let's clean all of this up so it's easier to read, and we can see where we have to go from here. These are all steps that you should show in your work, on your quizzes, and on a test. So I have 3 multiplied by 2m plus 4. Here I have 5 multiplied by 3x plus 2. And if you want, you can multiply this out here. 4 multiplied by 15 is 60. Our next step is to do distributive property, gather our like terms, and solve. I have 6m, 3 times 2, plus 12, my 3 times 4, subtract 15x. Oh, we lost our addition sign in here. I'm just going to squeeze that in. 3x plus 2 there. So I just did 5 times 3x, which is 15. I'm going to do negative 5 times positive 2, which is negative 10, which equals 60. Gather like terms. 6m, subtract 15m. Let's see here. Let's be sure all of our letters stay the same. Okay, see if I can correct this as well. All of our variables should not have changed here in the question. So let's just keep in mind that these are m's and these are m's. Okay? Because keep in mind, if these were x's, we can't add and subtract them together. They're not like terms. So you might want to organize your work, or you may be able to do it just visually. But here I have 6m, subtract 15m. If you need to write them in order, please feel free to do so in your notes in your homework. 6m minus 15m is negative 9m. The next thing that I do is I take 12 minus 10. These are like terms here. 12 minus 10 is positive 2, which equals 60. Now that we have simplified this, we need to again have our variables on the one side and our constants on the other. So we're going to move that positive 2 to the right side, trying to isolate for this m. Equals 60, subtract 2, negative 9m is equal to 58. Divide this side by negative 9. What I do to one side, I do to the other. These cancel out, and we have negative 58 divided by 9 left. So m is equal to 58 divided by 9. That fraction cannot be reduced any further, so our question is complete. If we were to substitute a negative 58 divided by 9 into our m's in the original equation, our left side would equal our right side. So here's the question I want you to try on your own and bring your work into class, and we'll take it up together at the beginning of class. 3x minus 5 divided by 6 plus negative 2x divided by 4 is all equal to 3x divided by 2. Keep in mind the trick is to first remove all of your denominators with a denominator that's common, lowest common denominator. You'll have some distributive property to do, and then you can solve the equation.